Sound is the vibration of air molecules. We can represent vibrations of sound waves in graphs. For example, the sound of my voice right now makes a vibration that looks like this. As you can see, this is a very complicated wave, but not all sounds are so intricate. Sine waves are the simplest waves, and they sound like this. This sound vibrates the air at 331 cycles per second, creating a gentle hum, also known as E-flat. Here's a little experiment with sound. I'm taking these simple sound waves and adding them on top of each other. I've hacked together a simple program in MATLAB that draws a sine wave graph, and then it lets you play back the sound it represents. I can change the frequency, or pitch, and the amplitude, or volume. But what happens if we layer two sine waves on top of each other? Let's make a sine wave, and then add another sine wave that has 1/3 the amplitude but 3 times the frequency. So the first sine function sounds like this, the second sine function sounds like this, and together they sound like this. And they make this weird tooth-shaped pattern. Let's add another layer, this time 1/5 the amplitude but 5 times the frequency. Yeah, it's a pretty annoying sound, but look what's slowly forming as we keep going in this odd number pattern. The highs and lows of each number line up perfectly in such a way that a brand new wave shape forms. As we approach infinity, we get a square wave. And to me, that's kind of beautiful. With the power of infinity, you can take a group of perfectly smooth waves with no sharp corners and combine them to get something rectangular with only sharp corners. By the way, this series of sine waves added up to form a new shape is called a Fourier series. But after I created a square wave, I immediately wondered, what's so special about the odd numbers? In the next video, I'll look at harmonics and the sawtooth wave.